Hi there, this is Mindy, and in this short video I'd like to share the way to sign data to blockchain by multiple parties, and which actually I shared on the GitHub Mindy ident. This repository has a utils sh file which contains the functions to sign a directory or a file to a blockchain, and by multiple parties produce a signature to verifiably prove that a certain set of parties had seen a particular set of data. So for example, let's say we have raw data like this, which is just a couple of videos in a folder. And what we will do now in a couple of minutes is produce something like this, which is the same data files, but they are actually with a file which is a signature file. So it's like that, and this file then contains a set of signatures, and it will contain the signatures by multiple parties from different computers. So to do that, to demonstrate that, I had also opened a Windows computer here, which has this folder synchronized with this folder, so that we don't have to jump around. Now suppose that now there are two parties, this is me and someone else here, and they have a file, let's say an empty folder like here, with some files. And let's say that you want to get someone like your friends or participants in the meeting that produced all these files to sign them, to cryptographically sign them. What you do is just maybe create the folder data and move all the files to that folder. Now you have the folder data, and then in fact there are utils, particular utils that I had written. So you edit the bash RC file. In fact, let me actually go to the description of how to do this. This is the functions. So these are the functions to copy to the bash RC file. Copy that to the bash RC file here, and pretty much it could copy them anywhere, and paste, right, and save it, and then just type the source that bash RC file, and then you have the commands such as the command solve, the command dhash, and the command sign. And then basically just sign, type sign and data, and you click enter. This will compute the manifest file for all the files in the data folder, and it asks me, do you want to rename the folder to hash value of the initial value. I will for now do it not. So what happened now is this file was produced with my signature inside, and additionally what happened is, if I show, the manifest file was produced with the hash 256 SHA checksums of each of these files, and if there is a hierarchical tree, they are also produced and then ordered just by alphabetical order. So this manifest file means basically anyone can check that these files are, at least that they have the same hashes. Now then let's say another person wants to sign. So that other person is using, let's say, Windows computer. So this other person finds here and says, hey, there's a, in the docs of ident there is a description, let's say, how to do it in Windows. So in Windows they need to install the git bash, basically download and install, and then generate the key, basically just run let's suppose that I have no keys. So let's say I remove SSH, DRC, and DRC pub, which are the keys, and let's say this is a clean machine. So I just run this to generate the key pair, okay, and then I actually have to again, as it says, add the utils sh content into the bash RC parameter. So the bash, this utils sh, again, the same content. Copy that content into the bash RC. Yeah, just go to the bash RC and then copy that content. Actually, in this case, it was already copied. Yep, then save it. Then you want to do this source it, so bash rc, and then the commands will become available. So particularly, for example, solve command hi. It produces the response to a challenge message hi. So now let's go to that folder where we just had, let's D to this folder. And now, till now, we just had one signature by the previous, computer. But let's say I want to sign it too. So what we do is basically there is data folder, right? Just do sign data. That's all that the user, has to do. And then just enter. And once you see that, you can click enter again. So another signature was added to this. Right, there are two signatures now. Well, if I just try to here as well, to look at here as well, one is by one machine and another is by another. So you can imagine that there can be really many signatures by different people who have different machines. So these signatures are going to the sign .sign file, which is in fact the hash. Before the .sign, there is a hash of manifest. So if you look at this, it kind of created that manifest, right? So if you compute SHA256 of the manifest, it's that value. That value is included into here. So now the final signing off. So basically, by this point, you have everything that is needed to really write this folder into blockchain. But what I suggest to do is add the final signature. So sign data again, and in this case, type yes. So it's Y, and what this means is basically that you want to rename the original data folder to the hash value of the signatures file. So if you just compute the SHA256 of the signatures, right, it is 3B21, etc. And this is the name of that folder of the data. Now that is now these a couple of things, including the names right here. The folder contain all the necessary information to, the hash of the signatures, the hash of the manifest, and also the files themselves and the manifest itself. Finally, what you write into the blockchain is this value. So, for example, let's write this to a blockchain. One of the easy ways is to use, for example, to use Ethereum. Ethereum, let's say, Classic is a lot cheaper now, and my Ether wallet. So let me copy that value here, and then let me go here into this and use this MEVCX access way and access my wallet. I have configured my MetaMask to work with Ethereum Classic, and what you can do is just click send, and then choose your let's say your own account, because you don't want to really send to anyone else right now, just one, and choose this and just paste that data. So we can actually just paste this data here, and then click send transaction. Now this pops up, the Ethereum, and asks you to want to actually send. You can click confirm, and then that transaction is actually initialized. So you can also sign that. Let me let me see when it will appear. I can click on here. Yeah. Oh, it's still not appear. So what we can do is, for example, start with copying the transaction ID and adding that transaction ID into TX file, for example. So I can say etc and the transaction in etc transaction is this. So anyone can now check that this hash is in the Ethereum Classic blockchain. And if they open, let's say, okay, activate. So now it actually went through. So if they open that transaction, they can verify by just copying that file and taking a look. Oh, it is here inside the raw output in this blockchain. So similarly, you can easily save your hashes into other blockchains as well. And that basically finishes the short presentation on this capability. Okay, so